All right, guys, in this video, we're going to look at something new with matrices that is also going to be helpful for us with we work with our systems. And we're not going to get to the systems part today, but we're just going to start to understand a little bit about what we call identity matrices and then inverse of a matrix. So the identity matrix, which we just call with a capital I, that's how we name it. It's different for each size, but if we had a 2x2 matrix, the identity matrix looks like this. Okay. And it looks pretty familiar to you because that looks like reduced row echelon form, doesn't it? If it's a 3x3, the identity matrix looks like that, and you can imagine what the 4x4 and so on would look like. Okay. So if I call this matrix A, what happens when I take A times the identity matrix? Well, this would be 1, 3, 2, 4. Because this is a 2x2, the identity matrix that we would use would be 1, 0, 0, 1. Okay. Now, I don't need to grab my calculator. These are just 2x2s. I can multiply these pretty quickly, and it would be a good reminder for us on how matrix multiplication really works. Remember, to get your top left spot, you take your top row times your left column. And what happens here? We have 1 times 1 plus 3 times 0. Well, 3 times 0 is 0, so we just have 1 times 1, which is 1. Now, when we go to the top right, we take our top row times our right column, 1 times 0, which is 0, plus 3 times 1, which is 3. Let's go to the bottom left. Bottom row, left column, 2 times 1 is 2, 4 times 0, that's just 0. This is 2. And lastly, bottom right, bottom row, right column, 2 times 0 is 0, plus 4 times 1 is 4. And what do you notice here? When we take A times the identity matrix, what matrix did we get? Well, we got matrix A back again, didn't we? Okay. Now, that's not super surprising to me because we've used the word identity here. If we think about just some simpler mathematics like addition, what is the additive identity? The additive identity is 0 because if I take any number such as 3 plus 0, I get 3. I get back what we started with. What is the multiplicative identity? The multiplicative identity is 1 because if I take any number times 1, I get that same number. Identity, you get what you started with. What's my identity? My identity is me. It's nothing different than me. Okay. So when we take our matrix A times the identity, we get matrix A. What if we take the identity times A? What if we switch the order? We saw before that the order that we multiply matrices matters. So what happens if we switch this and we go 1, 0, 0, 1, the identity matrix in front, then times matrix A? Okay, I'm not going to do all the colors and everything. I'll just talk through it. Top left, 1 times 1 plus 0 times 2, 1. Top right, 1 times 3 plus 0 times 4, 3. Bottom left, 0 times 1 plus 1 times 2, 2. Bottom right, 0 times 3 plus 1 times 4, 4. And again, we get matrix A. So here's what we have. Okay. For any n by n matrix A, so that tells us we have to be dealing with a square matrix here. Those are the only identity matrix that we have for multiplication. A times the identity is the same as the identity times A, which is the same because they're all just A. Okay, so that's the first thing we need to understand in this video is our identity matrix. Okay. All right, now we're going to talk about inverse matrices. And if we think about how we've used the word inverse before, okay, we've talked about inverse functions, and this inverse has an applied meaning here. What's going to happen if I take a matrix times its inverse? Okay. If I take a matrix times its inverse, we think about inverses canceling each other out. We're going to get the identity matrix. And if we flip the order and take the inverse of the matrix A times A, we will get the identity. So it's the inverse matrix if and only if when you take A times its inverse, you get the identity, or if you take the inverse times A, you get the identity. So what we need to look at is how do we find this inverse matrix, and then let's just check and see if it really works. So what we use is an augmented matrix to find the identity. So here's that matrix A that we've been working with, 1, 3, 2, and 4. And we know an augmented matrix means we draw a line and we put something to the right. And when we were doing this, when we were solving systems, our augmented matrix was just one more column. What we do here, and it's really clever, and there's multiple ways to find an inverse of a matrix. I'm just going to teach you kind of my favorite way. And I'm going to put the identity matrix right next to it. Okay. And what we do is we make the left into the identity matrix. And as we're manipulating this to make it into the identity matrix, this is going to change to the inverse. So we start with A on the left and the identity on the right. And we change it so the identity is on the left and we end up with A inverse on the right. Sound like a plan? Should we go for it and should we actually see what this looks like? All right, so what we can do is, let's see here, how do I make this into that reduced row echelon form? Well, I've got that 1 in the top left, so I like that. That's going to stay the same. So top row stays the same. Bottom row, I know I want a 0 here. So how am I going to get a 0 there? I'm going to take -2 times row 1 plus row 2. So -2 times 1 plus 2 is 0. -2 times 3 is -6, plus 4 is -2. I have to still do it on the right. -2 times 1 plus 0 is -2. -2 times 0 plus 1 is 1. All right? Next step. My next step is to take this position and make it a 1. I'm going to do that by multiplying everything in the bottom row by -1/2. 0, 1, 1, -1/2. Multiplied everything in the bottom row by -1/2. Now, when we're getting using this with our matrices before we used our calculator to do this, we were getting into row echelon form, not reduced row echelon form. So I actually need to do one more step here that we haven't talked about, and that's to actually go up here and make this a 0 now. So how am I going to make that a 0? Well, we like our bottom row. Our bottom row is actually done. Okay. I'm going to make this a 0 by taking -3 times the bottom row and adding it up. Okay. Now, if I take -3 times 0 plus 1, that's still 1, and that's good because we can't have that change. We need that to be a 1. Okay. That's why we come down here, we make this a 0 first before we make this one a 0. All right, now over here, we're going to take -3 times 1 plus 3 is 0. -3 times 1 plus 1 is -2. -3 times -1/2 plus 0 is 3/2. Okay, so we've got the identity matrix on the left now. On the right is our inverse matrix. So we're going to say A inverse equals -2, 3/2, 1, -1/2. Now, how can we be sure that that actually is the inverse? Well, we know this has to be true if it's the inverse. If I take matrix A times its inverse, I have to get the identity matrix. So let's check it. Let's take A times A inverse. All right, what was A? 1, 2, 3, 4, like that, I believe. Yep. And our inverse, we got -2, 3/2, 1, -1/2. All right, let's multiply and let's see what we get. Top left, I will write this one out because there's a lot going on here. 1 times -2 plus 3 times 1. Top right, 1 times 3/2 plus 3 times -1/2. Bottom left, 2 times -2 plus 4 times 1. Bottom right, 2 times 3/2 plus 4 times -1/2. All right, let's see what these are. That's -2 plus 3, which is 1. This is 3/2 plus -3/2, which is 0. This is -4 plus 4, which is 0. And this is what? 3, right? And this is going to be what? -2. 3 plus -2 is 1. And we got the identity. Now, I should also check A inverse times A and make sure that gets me back to the identity. I'll leave that to you. Okay. Now, I do want to show you that, again, the advantage of the matrices is using our technology. What I can do is I can put this augmented matrix into my calculator. Let's see, where did my calculator go again? There it is. So I'm going to choose matrix. Let's edit matrix A. And now let's make it a 2x4 matrix. And we had 1, 3, 1, 0 across the top row. 1, 3, 1, 0. In our bottom row, we had 2, 4, 0, 1. Now what we can do is let's quit out of that. Let's go to matrix. Let's choose math. Let's go to reduced row echelon form. And let's do that with matrix A. And this is what we get. And that should look familiar to you, right? Let's draw in our augmented, whoops, put it in the wrong spot. Let's put where, there we go. And take a look at this. There's the identity. And on the right, isn't that what we got for our inverse? -2, 3/2, 1, -1/2? Yes, it is. So you can use your calculator for this as well. All right, there's kind of our setup. Identity matrix, inverse matrices. In our next video, we'll start to learn how we can use this to solve systems. Thanks for watching.